All right, we're good to go. Good evening, everybody. My name's Tristan, and I'm a senior Ruby dev, but my background is in C++. So any opportunity that I've had to get into the nitty-gritty of Ruby, I've jumped on. Now, one of the themes of being a C++ developer in the Ruby community is that I'm going to spend a bit of time apologizing. That's how it is. So you'll see a couple of slides with C code, and yeah, no doubt I will apologize for that. So the topic we're talking about tonight is native extensions. So what is a native extension? A native extension is something that allows you to extend the functionality of Ruby using native code. So that's code written in languages like C, C++. More recently, I've seen people using Rust. It's a very popular contender. And what we're looking at in this talk is a bit of an example of how you can use a native extension to talk to a third-party library using Ruby. Now, all of this code can be found on GitHub. I'll give you a moment to type that into laptops or whatever if anyone is jumping ahead. But you might want to look at that after the talk. So what are some examples of native extensions? Bybug, which is a debugger for Ruby, is written in C for speed. Even though you could do that, all of the functionality in Bybug is available in Ruby itself. You wouldn't necessarily want that code basically injecting itself between every line of code execution in your program. Another is Nokogiri, which is an HTML XML parser. We need speed and standards compliance there. There's RMagic for image manipulation, and then SQLite, which uses SQLite's database engine directly. So what we're going to look at tonight is a library called libclipboard. It's a cross-platform clipboard library, just lets you access data that users have copied and pasted. It provides a pretty simple C-based API, so it's basically these four functions here. The two that we're most interested in are clipboard text and clipboard set text. That's for reading and writing to the clipboard, respectively. If you wanted to get a copy of libclipboard, unfortunately, it's not available on Homebrew. So the easiest way to do it is just to git clone, go through a few build steps using something called CMake. You may not have heard of CMake because you're not necessarily C++ developers, but it's basically just a build tool. It's as bad as all the rest, but it works. What we're going to do with libclipboard is wrap it in a really simple Ruby module. We're just going to call it simple clipboard, and that's going to provide two methods. One is called getText, and that's going to return the contents of the clipboard, and another is setText. It's going to take some new text, update the clipboard, and return the old text. So to actually do this in C, or as a native extension, we need to provide two files, just at a bare minimum. One is extconf.rb, and the other is a C file, simpleclipboard.c. So the first one, extconf.rb, is basically a description of the build process for taking your C file, compiling it in a way that will work with Ruby, and then spitting out a bundle that can be included using require. Here we start off with a require for this mkmf thing. That's short for makefile. We tell mkmf about the clipboard library. That's what's happening in this local libs-l clipboard line. If you're on Mac, you have to do some extra funky stuff and include something called appkit, and I'm really sorry about that. Finally, we do these two weird lines, create header and create makefile. They're pretty self-descriptive. Now let's have a look at the simple clipboard C file itself. I'm sorry. We have to start off with two things here. One is an include for ruby.h. That's basically the whole Ruby API. That's so say you want to write Ruby in C, and I actually do, but you probably don't. this is what you include. And then we include libclipboard.h itself, which is the libclipboard API. Now, if you squint a lot, this next block might actually look a bit like a Ruby function, or sorry, a Ruby method. That thing at the left, shouty value, that is what you call an opaque value in C. Basically, it says it contains some data, but we're not supposed to look at what that data is. And that's actually the same as a Ruby value or a Ruby variable. And so in the first line of this method, we see a value called result, and we're setting it to q-nil. So that's kind of like saying result equals nil in Ruby. In the next line, this is some actual C-ish stuff where we're calling the API for libclipboard, and we return a char star text. I'm really sorry. But that's a string. What we do next is we say if text, and this is actually a little bit more Ruby-like because we don't actually have to say if text not equals null and all that. That basically says, hey, the clipboard text function actually gave us a string value, so we can do something with it. What we have to do, though, is kind of ugly. We have to call this rb string new thing. And what that does is it takes this char star and turns it into a value that we can work with the rest of the Ruby API. Or, sorry, a shouty value. And then once we're done with that, we call this free function. I'm really sorry, but in C, you have to do memory management yourself. And so what happened when we called clipboard text is it returned some memory that we now own, and we're responsible for freeing it. If we don't do that, that's a memory leak, and you don't want that. Finally, return whichever result we ended up with. It's either going to be nil, or it's going to be this new rb string result that we got. And that's it. Like, that's the getText method. setText is kind of similar. There's a few extra steps, but I just omitted it so that we don't have to, so that I don't have to apologize too much. And finally, we've got this last function here called init simple clipboard. And this is kind of special. It's something that by convention, every native extension needs to provide. And the naming convention is init underscore extension name. And because the extension name here is simple clipboard, that's what I've used. Now, I kind of like this one because as a C++ program, it makes me feel warm and fuzzy defining modules in C++. And in that first line, that's all we're really doing. We're defining a module called simple clipboard. And then we're assigning it to a shouty value m. And then we use a function in Ruby's API called rbDefine module function. And we take that reference, we give the method a name, and then we pass it a name of a method, sorry, of a C function we want to call, and then finally the number of arguments that it takes. So after we've got these two files, we run ruby extconf.rb. That spits out a header file, which is redundant in this case, a make file, and then also a log of what happened. And then once we've got that, we can run make. And depending on the OS that you're running, this will produce a file called simple clipboard with whatever extension is appropriate, .bundle, .so, or .dll. I'm really sorry if the OS that you're using spits out a .dll. Now, how would we use this native extension once we've built it? It's actually really simple. If we were using IRB, we'd do require, and in this case, it's /simple clipboard. The // is required because we haven't installed this gem or installed this native extension anywhere. It's just in the current directory. Sorry, it's a different apology that time. Now, actually using this module is really simple. It's just simple clipboard.getText. And a little detail here. The reason we call define module function is that this is actually a wrapper around two steps. It creates both a module method and also a static method as well, so that you can call this method either on the module itself or by including it in another class, which is kind of cool. So that's pretty much what we'd expect. I feel like I've summarized most of this, but so for an extension called XYZ, we need extconf.rb. We need a source file called xyz.c, and that should provide the init function. Now, to sum up what a native extension can do, it can define modules, classes and methods that operate on Ruby values. It can call existing Ruby code. It can crash the current process, and more generally, it can call undefined behavior, which is basically what C programmers call the parts of the C language spec that are poorly defined. So it's like, we decided not to say what this method or what this function should do. It could just erase everything on your hard drive. Sometimes it does. So how do we actually package this up in a gem and make it really nice to use? Yeah, safety be damned. This is the structure that we'd have for a non-native gem. There's a lib directory, had some source code in it. You know, we split out the version.rb and all that, and we have a gem spec. When we have a native extension, we kind of mirror this with this ext directory that has simple clipboard in it and those two files that we required before. So what does the gem spec look like? Well, we have the normal boilerplate. That should all look pretty familiar. And then we have this extensions array that we have to provide. Just basically just an array of all of the extconf.rbs for the different extensions we want to include in the gem. And we also add the source files to the files list because we need to bundle them as well. They're going to be compiled on the end user's system. Then we call gem build using that gem spec, and that will spit out the gem file that we can then install. Now, the interesting thing is when we go to install the gem, that's when the code is actually compiled. And so that's why when you, how many people here have had Nokogiri explode on them? Yeah, I thought I'd see a few hands. That's because it's compiling against some fairly complex native libraries, and if there's any discrepancy in how that's set up on your system, that's going to cause pain. This is an example of when everything does work. No apologies. And then if we were looking at this in IRB, it's basically the same, except now we don't need the / on the require line because this gem is installed in our system. So what about testing? Testing gets a bit trickier because now we have to have a workflow where we both compile and run tests when we're making changes to our C code. Now, the easiest way to do this that I've found, there are others, but this seems to work well, is to add, first of all, a rake file and to define a couple of tasks in that file. In this case, I had rspec tests. So I defined a spec task. And then I use this thing called extension task, which is able to take our native extension, compile it, and then install it in a local temp directory so that it's available to our test suite. And then finally, I define the default task to run those in sequence. Now, the reason I split that out is because we really want to be able to run rake compile or rake spec separately. You know, you don't necessarily want to recompile your code every time you want to run your test suite, especially if you're just modifying Ruby code. And there are also times when you don't want to run your test suite while you're just trying to debug those excruciating C compiler errors. In that case, rake compile is really useful. But most of the time, you'll just run rake. Now look, that's probably a good point to wrap it up. I thought I'd share some useful resources with you. Probably my favorite would be Ruby Under a Microscope, which is a book that goes into great detail about how the Ruby interpreter works. And although that isn't specifically about writing native extensions, reading this book has given me a really deep appreciation for how awesome Ruby is as a language, how awesome MRI and JRuby are. The core documentation is also really useful for writing extensions. And this top link here was a really useful reference implementation of a gem with native extensions. That's where I stole the RSpec stuff from. What else? Chris Lalensets, I think I've said his name correctly. The in-depth series on writing Ruby extensions is incredible. It's in 12 parts, goes into amazing detail, and the way he's broken it down is really useful for when you're trying to solve just very particular problems, which is sort of the methodology you'll have if you're writing a native extension. You'll want to work with arrays or strings or some subset of Ruby functionality, and you don't necessarily want to understand it all. Ruby Gems documentation is great, and Aaron Bedra's Extending Ruby Guide is a good bird's eye view too. So with that, thanks for listening, and I'm open to any questions.
Questions?
Be gentle.
Yeah, I will be. Great talk, thank you. It's something I've wanted to do for a long time, but I haven't. Two questions. One, are your slides going to be online somewhere so that I can find those links later on? And two, have you written any extensions in Rust? And is there any kind of learnings or anything different from what you've said there to do that in Rust?
So first question, the slides will all be available. And bit of a sneak peek, I've actually written a blog post about all of this as well, which I'll link on the meetup page either tonight or tomorrow. So that has a bit more detail about how all this stuff works. And of course, there's the reference for the simple clipboard repo, which I kind of think is a really good, just simple example implementation of a gem with native extensions. Now for the Rust stuff, I haven't actually used that myself. I've just seen that it's possible. I know a few people who would be more than willing to talk about that in more detail though, so maybe I should word them up.
Anyone else? Good. There you are.
It's really cool stuff. What sort of, on a more basic level there, what sort of things do you tend to want to be writing native extensions for? Like what sort of use cases are they best utilized for? You said speed, so...
Speed, access to legacy functionality. So it's not just languages like C, but anything that has a C compatible API is fair game for a native extension. My personal motivation for learning about native extensions in the first place was that I had written a data structure in Ruby called a partially persistent tree. It's just like a versioned tree where you can access the tree at past points in time. Mm-hmm. That is not super performant in Ruby and has a fairly large memory footprint because of all of the dereferencing and everything else that goes on. And so I started writing that in C++ to try and improve those behaviors and have access to things like C++ templates, which are useful for that kind of problem. And that code is incomplete and fairly hairy, which is why I didn't show it. But for me, it's the ideal use case for native extensions.
Cool. I guess it'd work well with hardware things as well if you wanted to just go directly.
Yeah, so there are people out there who are using native extensions to talk to GPUs and, CUDA, OpenCL, things like that. So that means that you can pretend to be a Python developer or a data scientist for a day without going outside the confines of Ruby.
Thank you.
On the other side, are there any use cases where it would be not only not much improvement to go with a native extension, but perhaps actively harmful to performance?
That's actually a really good question because it makes me think about safety more than anything else. So you might be able to gain an extra 20% performance or reduce your memory footprint by 20%. But if in doing so, you increase the development cost dramatically by introducing the complexity of C or C++, then that's not a win, or most likely isn't a win. Probably anything where you are writing complex business logic as well from scratch. There's little to be gained from doing that in a native extension. Just think, if your problem can be encapsulated as a really tight loop where you throw some input at a function, it churns away for a while and then spits out a result, that's ideal. But if your code isn't doing that, you're going to incur the overhead of calling the Ruby API and everything else, which will negate the benefits.
Cool. Any other questions? All right. Thank you, Tristan.
Thanks.